Thanks everyone for coming to the Riak workshop. I'm used to running user groups, so I'm kind of going to run this like a large, long user group. And one way I like to start is by going around and figuring out who's here. So yeah, we're going to do that thing. I'm Casey. I work at Basho. I'm on the ProServe team, so I'll go out to clients and help set up Riak, run proof of concepts, and do training. So this is our agenda for today. It's going to start out pretty high level, very high level, pretty light, and we'll quickly. Well, we're going to go through everything quickly because one day isn't a lot of time to go through this stuff. But we'll get down to actually working with Riak. So the point of this is to educate you enough that when you leave, you know whether you want to use Riak, and if so, when, and how to get started. We will have lots of time for questions. Feel free to interrupt during the presentation if you have questions, but we'll also have at least 2 breaks where other people from Basho will be walking around and you can ask more specific questions, deployment related or not. Okay, so how many people here have actually used Riak? Okay. All right, so we're going to start with a really high-level introduction to what Riak is. This is me, by the way. Message me, send me an email. So, Riak is a database. It's Apache 2 licensed. We have a lot of community contributions. We're very dependent on the open source community for contributing functionality and fixing bugs. We have something like over 250 contributors at this point, I think. It's a key value store. So you give Riak a key and a value, it saves the value. You give it just the key, and it returns the value. It doesn't care what the value is. As far as it's concerned, it's just a binary blob, so you can store whatever you want in there. It is masterless, so there's no single point of failure. In Riak, no node is special. There's just one binary file for running a node, and it's the same for every node in your cluster. All nodes on the cluster accept requests. So again, it's masterless. There's no temporary master or anything like that. It's a distributed database by design. Our default configuration is a cluster of 4 nodes. Anything less than that doesn't make a lot of sense for Riak, since its distributed nature is key. The data is spread among all of the nodes, and we'll get into a lot more detail about how that data is distributed around the cluster.
Nodes have to be separate machines?
Nodes should be separate machines. So, and we'll get into lots of examples of deployment, but yeah, it wouldn't make sense to have more than one node on one machine, because one of the key value propositions for Riak is that it's fault tolerant. Since every node is identical, all nodes are equal. If a server goes down and it has more than one node on it, that doesn't make a lot of sense. Right? So we make it fault tolerant through it being distributed, through replication, and we'll talk about how the data is replicated throughout the cluster. Some of our fault tolerance is also kind of lent to Riak through Erlang OTP, which is a language construct that kind of made Riak possible. Obviously, being masterless adds to it being fault tolerant, because there's no one master that if it goes down brings down the whole database. And so it's designed to survive node failures, network partitions, and other software failures. It is eventually consistent. So it's not ACID compliant. It's not strongly consistent. If you ask different nodes at the exact same time, there's a small, for a value, there's a small chance that you'll get different answers. So the idea is that all of the nodes are working towards the same state constantly and very quickly. But it does leave some room for minor consistency discrepancies. And this is just the nature of a distributed system. Data takes time to propagate through a distributed system. We're no different. There's actually a logical trade-off between strong consistency and availability in large distributed services like Riak. And Riak doesn't hide this trade-off. Rather, we kind of give you tools to let you control it. Different options for controlling your consistency and availability. Which brings us to the next feature. It is highly available. So because any node can serve client requests, we have fallback nodes that respond when any particular node is down. As long as you can connect to the database, to the cluster, it will accept reads and writes, even in failure states. Even if some of the nodes go down, it will still record and serve your data. This also gives it a very low latency because all of the nodes are working. We don't have special nodes that just do reads and special nodes that just do writes. Each node does both. Because of all these features, it scales. It scales so big I couldn't fit it on the slide. So when you need more throughput, disk space, processing power, when you need more something out of your database, the key to getting more power from Riak is to add more nodes. So it does scale horizontally, and we do have lots of data and experience to show that we scale linearly horizontally, which is great not just for reacting to performance issues, but it's also great for capacity planning. We can build a small cluster and spec it, figure out what the operations per second are, for example, and then figure out, based on what our use case is, how many operations we want to handle a second, how many nodes we would need to serve that. And so we have a very reliable horizontal scaling capability. I'm going to briefly go over the native APIs that Riak exposes. So one is HTTP, very easy. Everyone here should is probably familiar with HTTP. It sounded like you all have a technical background. So we have an HTTP REST API done right. We took REST pretty seriously. So we built in-house a program called Web Machine, which is a great Erlang program on in its own right, which is basically a functional instantiation of the HTTP request cycle. So it plays very well with HTTP infrastructure, load balancers, caches, proxies, web servers. It just kind of fits into the normal infrastructure that you'd expect. We also have a way to interact with Riak using protocol buffer. This is a binary communication protocol and serialization format designed by Google. We have support for that in dozens of languages. It's basically just a little bit quicker than HTTP, a little bit more efficient over the wire. We have a lot of client libraries. So Riak is written in the language Erlang, so it makes sense we have a client library in Erlang. We have a very feature-rich client in Ruby. Java, you kind of expect Python. A bunch of other ones. A lot of these are community supported, like the .NET one. So JavaScript, Node, Haskell, C, C++, Clojure, Scala. Anybody know they're going to be using a language to connect to React that's not listed up here?
Yeah, we're using the older PHP client. I guess we can allow that.
PHP, okay. Yeah, I didn't list PHP, but we have a client for that too.
So in Java, is it like a standard interface, like a JDO, or you have your own JDBC or something standard, or what do you guys?
I actually haven't used the Java library. Anyone?
It actually, it isn't JDO or JDBC, it's direct calls into a server using either protocols or that. You set up a connection with the API and just make a call.
So I can't use like standard, like some OR mapping kind of thing.
No.
So no, yeah. So an object relational mapping wouldn't really make sense with React since it's the key value store.
JDO kind of tries to bridge the gap. There's a REST call.
Yeah, I mean a REST call. So I've seen enough Java code to know that making a REST call. Well, so using the protocol buffer connection would be a little bit more efficient through Java, and we can get into this a little bit more later. But it's so trivial to do. I don't think you would need an additional layer on top of there to handle anything else for you. Okay? Okay, so just to quickly go over, Riak, it's a key value store. So it's not a document database like Mongo, I think you wanted to compare it to. It's masterless, it's distributed, fault tolerant, eventually consistent, so it's not ACID compliant, highly available, and scalable. The native APIs are HTTP and protocol buffers. And we're going to talk mostly about the HTTP connection, just because it's easier for everybody to inspect. And client libraries, pretty much your favorite language. Okay, so that's the very, very high-level introduction to React. That'll kind of set the pace for the rest of what we're going to go over. So next short segment will be key concepts, kind of like a glossary of terminology so that we're on the same page. We're going to take 5 minutes, just, there's food in the back. Go to the restroom if you need to, and we'll be back in 5.